Ladies and gentlemen, our team is vertical axis wind turbines along the highway. Our team members are Dennison, myself, Erik Gutierrez, Edwin Moore, and our faculty advisor, Dr. Basil. Motivation for this project started off in a mechanical design project. We did some research and found out that vertical axis wind turbines are a thing of the future and should be worked upon, as well as promoting green energy. The 3% of the world's energy produced is wind energy, producing about 700 terawatt hours, is shown right here, 3%. Now, the United States accounts for 4% of that energy, producing 182 terawatt hours. Now, as you can see, the United States also produces 26% of wind energy worldwide. That's a good margin, but it also produces 18% of coal energy, which we kind of want to get into that and stop the dependency on coal energy. Florida produces no wind energy, even though our average wind speed area is 12 miles an hour, which it seems like pretty weird that we don't look into that. Edwin Moore will now be explaining why this fits into our project and the difference between watts and hots.
So we chose to go with a vertical axis turbine rather than a horizontal axis turbine for many reasons, most of them relating back to cost. In a vertical axis turbine, there's several components that are not necessary as they are in the horizontal ones, which I'll talk to you more about later. The second part is that there is less mechanical strain on the shaft of a vertical turbine rather than a horizontal turbine, because in a vertical turbine, the generator and other of the heavier parts are not located at the top of the turbine, but rather at the base, which also will come into play later. The third part is that the blades on a vertical turbine also go through less mechanical strain than in a horizontal one, because in a horizontal one, they're only connected to the rotor in one place, whereas in a vertical one, they're connected in multiple places, which helps distribute the load that they are being transmitted onto them. You might be asking why we chose to want to do it along the highway. Well, instead of constructing a huge wind farm and clearing out land, roadways already have cleared out land. They are free of most obstructions that would hinder wind flow. The second part to it is coming back to why there is less mechanical parts in a vertical turbine. They're said to be omnidirectional. So if the wind starts blowing from the northwest and then changes coming straight out of the east, the turbines don't have to stop and readjust and reorient to the wind. They'll just continue to spin. We also hope that they will use multiple wind sources. For instance, the natural wind that happens in Florida of about 12 miles per hour, as well as wind coming off of passing cars to help rotate the turbines. These turbines also operate in lower wind speeds, which is good because even if there's no traffic, they should still continue to generate electricity just off the flow of wind in Florida. They're also less complex and they're cheaper to build, so we can build multiple turbines for the cost of what it would be to create one huge horizontal turbine, and then we also don't have to worry about if there's a hurricane, what are we going to do with this giant turbine? They're smaller turbines, they're easier to maintain, safer to maintain, and if we had a lot of them and a few of them went down, we would still continue to produce electricity from the rest of them, rather than if we lost one turbine and there goes all the energy we were producing. One turbine that we modeled ours after was able to produce 3.5 megawatt hours of electricity annually off of 10 miles per hour worth of wind. So if we can get somewhere near that and have multiple turbines, we would do the same job as one giant horizontal turbine that produces large amounts of electricity. And they'd be even easier to maintain because instead of climbing into a giant shaft in high wind speeds, you would just be able to pull off on the side of the road and get out and do any kind of operational problems that that turbine might have. And in order to prove that this is a worthwhile project, Daryl Hart from Next Air Energy was nice enough to give us an anemometer so that we could go out and do field testing. We plan on mounting it to a pole and having maybe ourselves or a few of our friends drive past us on a road so that we could see just how much wind is coming off of cars at several distances away from the roadways and at several different speeds to help simulate what it would be like on a highway. The second part to it is that we're going to make a scaled down model so that we can put it inside the wind tunnel that we have upstairs in the transport lab and see just how much energy we can produce from a smaller size part of this model. Now Michelle's going to tell you more about the design process.
Okay, fortunately, we do have access to a few resources here at FIU that can help us to achieve success in this project. Right now, we're looking at 3 different airfoil designs for the blades of the turbine. For specificity in this project, we decided to focus on 3 components of the turbine, and there are many components of the project or of a turbine that can affect its efficiency. We're focusing on the blade design, the bearings, and also the connecting rods or the arms that connect the blades to the axis of the turbine. We're going with the Darius type wind turbine with an H structure, as that in our literature survey and research has proven to be the most efficient and easiest to model type of turbine. It's also very effective in multi-directional wind collection, which is important for our application. As Eddie said, we are going to test these different shapes of the airfoils by 3D printing them and then placing them in the major cloud upstairs. The bearing is the most important part of our design because it is where most of the efficiency is lost in turbines. This bearing here is about $40, so it's a high price point. It's important that these materials be weather resistant as they are going to be exposed to the elements on the highway and could be exposed to different kinds of debris as it is a very active area. This here is a carbon steel polymer cage bearing with a rubber seal. It will be very effective, but we're currently looking for a cheaper alternative. We have a more specific goal, which is to power street lamps along the highway. An average street lamp requires about 2 kilowatt hours per day to remain on for the necessary amount of time. And each turbine that we're looking to design, we have a goal of reaching about 10 kilowatt hours per day, which would mean it could power 5 street lights, obviously. The important aspect of this is creating an inexpensive design that would be effective and require little maintenance when it is exposed to elements along the highway. So we have a price point of about $200, which has been pretty challenging to come to. And then we're trying to get the cost of the electricity produced by these turbines to be under 12 cents per kilowatt hour. This goal is comparable to the cost of solar energy in Florida right now. In a global perspective, we hope to contribute to the green energy movement and to harness the potential energy that is wind and go outside of solar, which is what most people think of when they think of green energy. There are other sources out there, and wind should be considered as one of the main ones. This project can be applied to any highway, and it has been applied on different levels and in different kinds of applications. In California, at Caltech, there's a professor that has installed these turbines with success, a different version of them. We're trying to improve on his version. We've deeply studied his work, Dr. DeBerry. There's turbines at Detroit National Airport. So there are all different kinds of applications that are happening now, and we're hoping to make an even better version that can be applied in other places. And we want to thank you for coming here today and for listening to us, and we hope to learn even more.
Questions?
Yes.
For your airfoil design, are you planning on using something that's already existing, or are you developing your own and running CFD analysis on it?
We're looking into what's been done before very heavily. We're considering not even just the shape, but also whether we're going to use a skeleton covered by some kind of polyurethane covering or like a cloth to put over it, or we're going to do a solid design. Right now, obviously, we want to make it as light as possible. We are basing our own design heavily off of previous designs.
I think there's a hotel in Fort Lauderdale Beach that has several of these up on the roof.
Yes, there are very many of them. I think even in Plantation, there's a very large scale one. We're trying to make them smaller so that they're safer, they're less disruptive to the environment, less dangerous as well.
You have a bird problem.
We do. That's one of the advantages of making them smaller, is with the smaller blades as well. They're less harmful to the birds. There's the ones that are installed in California that DeBerry did, he installed them in a way that there haven't been any bird casualties yet. So we're hoping to achieve the same results.
We love birds.
We like birds. We don't want to hurt the
I've
environment.
got bird feeders too, so.
Yeah.
The arms don't reach out as far as they do with the horizontal ones, so they shouldn't impact the bird fly zones. I mean, birds usually don't fly into light posts that often, so we're hoping that keeping the design from being too far out, it'll not it will track them towards running into it.
Do you have a political aspect to this? Because you got to convince the state legislature to allow you to sell electricity back to Florida Power and Light.
Yeah.
Yeah, that's why I talked to the gentleman at NextEra Energy. I actually ran this idea past him, and he thought it was worthwhile and wanted to know more about it as we continue to work on it. He did mention that there would be some issues dealing with FDOT about having something like this out there, but government is also big on green energy, and if we can come up with a safe design that would allow green energy to be possible in Florida and maybe start to eliminate some of the coal energy, they would face a lot of pressure to try to back this up, especially coming up with election years.
It's been really beneficial talking to NextEra. They've had a lot of valuable input for the projects and helped us a lot with our goals.
Yes.
We took our Baltic cruise a couple of years ago, and every little tiny Baltic country and Poland, Germany, all of it, as you fly over into Amsterdam, you fly over just hundreds of these things sitting out there. We're so far behind.
They haven't had a lot of success with theirs though. When I was doing the literature survey, there was a lot of places in Europe where these turbines were either not operational as often or actually taking energy from the grid just to run them.
I was in Germany just a month ago, and in the paper, they were talking about the fact that they're upset. They were running the turbines to keep the turbines alive. They weren't generating
Yeah.
power.
Yeah.
There's
that was
definitely a
what
lot
it
of
said.
opportunity
But
for improvement.
those were the horizontal ones.
Correct.
Right, those are the horizontal
Huge,
ones.
and they have
Correct.
a lot of maintenance issues.
That's what it was. Because the ones out in the water have to have a lot of maintenance issues.
Right, and then
Yeah.
they're exposed to salt water, so
Yeah.
it makes it even more difficult.
Well, when you looked at your wind for Florida, I think you got to be talking about South Florida.
Yes.
Yes.
Because we're in the trade winds. When you get north of something north of Palm Beach, you get out of the trade wind blowing at 10 to 15
It picks
knots.
back up when you get further west. When you get to the northwest side of Florida on the Gulf Coast, the wind speed there was higher than here, but just down here in southeast Florida, that was about the average that I could find.
Yeah, 'cause we
It
got
was
the
even
south-
higher in the Keys.
We got the southeast prevailing breeze.
Right,
Yeah.
it's
Well,
dead in the middle of Florida.
If you pick this last week in the Keys, it
Oh.
was 30 miles an hour the whole week.
Yeah, I was out on the patio for most of the weekend, and the wind was blowing the rain in. I'd sit there and I'm like, oh, it's a nice breeze, and the next thing I know, I'm getting soaking wet, and I'm a couple feet away from the thing. And I'm like, man, I wish I had a turbine right now.
So I would assume when you do this work that you're going to do some cost-benefit analysis
Yes.
to show us the payback and how long it would take based on
That was one of the
wind
big
speed
things.
and conditions.
Yeah, that was one of the big things NextEra was telling us about. We tried to do originally a calculation for the amount of money for the energy we would produce, and when I showed him what we came up with, he's like, what did you use for your cost analysis? And I said, I don't honestly know. I just kind of went off of what I found on another one, and we just converted it back to numbers that we could understand. And he said, yeah, but is that wholesale energy, or is that just what you're coming up with? And I said, I don't know. I don't actually know anything about that part of the business. And he said that they would help us with that, and we were trying to figure all that out.
The consumer costs.
Yeah.
Are you going to drive different kinds of vehicles by the roadside that you choose? Because, for instance, you know, a Prius and a box
Yes.
truck are going to have very different
Different
winds.
effects. Yeah, we were going to try to use an average. It would be nice to use different sizes, but sometimes it's a little hard to get a hold of a box truck and get them to go by. I was looking to go do it out west here where the dump trucks go by, but trying to get them to speed up or slow down so that we can figure out how fast they're going, it probably isn't going to go over so well.
We wanted to just go out on the highway and use the anemometer, but.
Yeah, but I don't know how
we experienced
happy
wind
they'll be when
resistance.
we're out there.
It's been a little bit difficult trying to reach the FDOT.
Right.
Do you have an allowance for tickets for people that are going 70 in the 30-mile-an-hour zone or anything?
Well, I have one of those
Stand on
things that
that
we're not
walkway
supposed to have
close
to
to-
do the police scanner,
Yeah.
so hopefully we'll see if they're out there or not that
The
day.
walkway near daylight, walk out at the top.
Yeah.
We'll drive down the ones at 30 to see if they're out there, and then maybe do the next one at 50 or 70.
I'm not driving.
Quick question. Do you
Yes.
have an idea of the number of blades you guys are planning to design and the ratio between the height of the blades compared with the total height of the
We're
turbine?
looking right now at a 30-foot, we're comparing our design to a 30-foot turbine that has 12-foot blades. So we're trying to use the same ratio to scale it down to build a model.
But we also have to take into account of how high we have to mount these so that there's no
Correct.
safety issues with vehicles that might pull off the side of the road or somebody who's stranded on the side of the road being close to the turbines.
And the number of blades? 4,
Five.
8, 5?
I think 5 would be
We're
good. The
going
one
with
that we
4 or
modeled
5.
after was 5 blades.
Why that number? Just,
It was the one that he had, and since we haven't done any experimental
okay,
values
so
yet,
it's your starting point.
we thought that
Okay.
it might be a good place to start and then maybe
Okay.
see how it goes. One of the big issues that we were thinking might be a problem would be the stability of the blades, being hit from different sources of wind while they're rotating, having more of them that were smaller and where they would be connected would be a big deal to make sure that the blades stayed stabilized, because one of the big problems I read online was that these turbines, they would kind of go off kilter from vibrations and everything. And that was one of the huge issues with keeping them maintained, is that these things start to kind of lean one way or the other way. So trying to find the middle ground for that would take, I think, a lot of time. And we don't really have that much time with this project, so going off of something that already exists kind of led us down
Yes.
that road.
Actually, building up on what you said, you're losing a lot of potential from having the big gaps in between your blades. So you might want to look into either wider bodies or more counts.
Blades.
Yeah.
Yeah, the numbers of blades and the height of those blades will optimize your system a lot.
The bigger the surface
Yes,
area.
correct.
Yeah.
Dr. Campos?
That's good.
Hello. Let him go.
Off the hook.